I'm Wild Bill, and I'm an artist with several major venue or media, one of which is the novel, the written word. And I write fantasy novels, and I write novels that I would call science fiction, but Arthur C. Clarke, one of the great writers who, who made laws about these things, so to speak, would say is fantasy because I include alien species in mine. Art Clarke only wrote science fiction that had no aliens in it until the very end of his life when he wrote Rendezvous with Rama. And then there was a series based on that with Chandra Lee, I think. And that was, you knew that Clarke was no longer in control because Clarke had said all his life, there are no aliens. And all his stories are about humans and terrestrial creatures and, the cosmos. So anyway, I have an idea that I use in my Hornox universe, in my Red Platoon stories. This is a concept that I don't think anybody's come up with before, but it's based on one that everybody's seen on television, and they don't know the name of it maybe. It's called Panspermia. And the idea of panspermia, the basic genital idea of it, see, I get to say sperm and genital in a reasonable conversation, has to do with the idea that all these chemicals that make up everything on Earth, make up all our bodies, are out there in space somewhere. And that probably they think, the panspermists think, that all of life formed in simple forms out in the molecular clouds somewhere, or in the parts of comets, cold chemistry I call it, because it happens like out away from the sun. And that chemistry over perhaps 1 billion years or 2 billion years can eventually randomized combinations of things that become, amino acids. We found amino acid precursors out there spectrographically, so it's not impossible to say that after another 100 million years you might get some amino acids in that cloud full of hydrogen and carbon and oxygen and everything else that you need for life. Yeah. So so you say this cold chemistry works. I'm not going to say it about panspermia because I don't believe that. That's just my prejudice based on the fact there is zero evidence for it. Science no longer depends on evidence. It's now big sweeping flights of fancy, and then they growl at you if you argue because you don't know. Yeah, but they don't know either. They're struggling to bring all their highfalutin theories into line with Newtonian mechanics, which is the only thing that we know that always works. And Newtonian mechanics is 300 years out of date. So anyway, oh, I'm not kidding. Newtonian mechanics explains almost everything we know, just like our basic theories explain everything that we know, but not dark matter or dark energy. Newtonian mechanics explains everything we know and can see, but it doesn't explain super microscopic stuff or ultra giant stuff. That's where Newtonian mechanics breaks down. That's where Einstein's work becomes significant because he talked about things that can be extrapolated to the very large and the very small. But the errors in his math appear too, and conceptual limitations of the human mind. I know people get mad at me when I say that. If you don't agree that that's true, then you're denying an essential fact of reality that nothing's perfect. So, not even a black hole, it radiates away over time. So, anyway, you have all the ingredients for life. So if you have a cloud with the ingredients for life in it, the same way the panspermists say that simple forms of life will form over a period of time with enough cold chemistry and no disruption of it, like by a star blowing up close by or something and dispelling the cloud. If you give it enough time, they think that these, a few hydrogen, oxygen, and carbon atoms will naturally link together and you'll get something that looks very much like one of the components of an amino acid. Well, that leads by extension to the idea that perhaps in time, with enough cloud area and enough of these potential interactions taking place, that you could make a model that could statistically predict that you could get a more complex form of this interaction. And so we move possibly from amino acid precursors to perhaps amino acids. Wow, those are major components of life. Now you're getting somewhere, panspermist. Okay? but you haven't found them yet. Well, you found the amino acid precursors. You haven't found any amino acids. So, and I don't think we will. I think there are reasons for that, but that isn't the purpose of my talk for today. I'm talking against my own conviction here to reach across the aisle to you guys. So we have this cold chemistry, and given time, it might form amino acids. At given more time, well, what are proteins made out of? Doggone amino acids. And once you get something that's like compelling, a really nice random juxtaposition of some amino acids in a certain way that make them very protein-like, right? You get what can be termed in certain fields of study a prion, a protein fragment, the kind that cause these terrible diseases or the conditions that old people get. I didn't read the research that proved they existed. I read a bunch of research that postulated their existence, and I had direct objections to that research. Doesn't mean I'm right. So I didn't read the groundbreaking paper that says, oh no, they're real. Anyway, but this prion can also be used in a big cloud of the right materials as a nucleating fragment. A nucleating fragment. Yeah. Did you ever get those little grow crystal mountains in your home, right? You have a little plastic container and you pour the water in there and you pour the solution in there. And then these little crystals grow, candy crystals grow in the water. That's a nucleant fragment. Your little pieces that you drop in there are nucleant fragments. And as the supersaturated sugar solution comes into contact with them, it tends to crystallize in a repetitive pattern based on that one. That's called a nucleant fragment. And that's what I'm talking about in these soups. They're very rarefied, but vast enough you have all the potential that you would in a smaller one in a soup that's got a concentration in it. So, we have all the right elements, we have a lot of time in cold chemistry, and we have amino acid precursors becoming amino acids. This is not a great leap of understanding, but when you recognize if you're using these predictive methods to try to use statistics to show that this could happen, you're dealing with numbers so fast that they could never be true if these models are anything like accurate, which they're not. We don't know enough. So anyway, but let's take this process and extend it, right? Just like we do with physics until it breaks down and see if we got an idea here. It's a Wild Bill idea here. So first thing that happens is you go from these amino acid precursors gradually become amino acids, which gradually accumulate in various places and come together, and somewhere along the line you get a protein. Somewhere along the line, enough of those potential protein, fragments get together and form a prion, which is a nucleant fragment. Suddenly, replication is taking place along the line, which is how DNA comes about, according to Panspermia. So, if this happens several places in this potential cloud, this giant cloud of, molecular cloud of all kinds of dust and material. Dust is anything that isn't hydrogen or oxygen, or hydrogen or helium again. Metals and dust mean the same thing pretty much, I think, to astrophysics. But anyway, when you get enough of these together, and they're not quite the same, in one part of the cloud there's one nucleant fragment making proteins, and in another part of the cloud there's another one. So let's say from the periphery of this cloud, this postulated molecular cloud, you have this gradually nucleating stream of proteins coming in. This one's different from that one, different from that one, different from that one. Well, they move into more dense space at the center of the cloud, right? And they start to interact. And you might get, as well as I said, it's only a very small chance for any of this stuff to happen ever, but you might get complexity. Yeah. One of these nucleon fragments might blend to another nucleon fragment, and suddenly they have a new thing, a new structure. If you put enough of these ideas together and say, well, this could go on for 14.5 billion years, right, or 13.9, or whatever they're saying it is now, because they always know, and then always shows that they were wrong, and that's why I say science is the codified remnants of all the mistakes, all the boneheaded errors, and conception and experimentation that we make along the way. It's not a trove of knowledge, because we're upending that knowledge daily. You will get, eventually, enough complexity. This is extending this idea out beyond reason, which is why I don't like the people that believe that there's life elsewhere, because you're extending these ideas out beyond reason. But I'm going with you here. So while Bill's on your side for the fact that you are important too, and your ideas are just as important discussion as mine are, even if I think mine are right. Okay. So now you get proteins, 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 and they're all nucleating towards the center of this giant, vast proposed molecular cloud. And they get close and they start interacting with one another. You start getting extensive differentiation, thank you, and then in time you might get something you, as a biochemist, might call structure. Wait, what? Structure. Yeah. Specialization and structure. So, in time, again, here on Earth it happens in 100 million years, so hey, out in space it doesn't have to take that long, right? So, you get differentiation. You could call those organs, as a matter of fact, those differentiated units, if they start becoming functional or potentially functional, because how could our liver work without the rest of us, right? But it is potentially functional as a separate entity. All right. So, what the hell is that song? So anyway, you get enough of this, and you get organs, differentiated organs. I mean, this is following this to the specious extreme, just like we do with Newtonian mechanics until we need Einsteinian physics. See what I mean? And that's I'm doing the same thing, following the same process that science uses, except they use a lot more math because they're left brain friendly and I'm right brain friendly. The big innovations in thought come from the right brain, but the number crunching that shows that up and makes the mathematical models, that comes from the left brain. I have only the one, and most of you guys only have the other, so you have to buy in rather than come up with your own ideas. Anyway, now you've got organs. You might say in time that this cloud, if it was big enough and had enough of these potential, nucleant replicant fragments that could possibly specialize and differentiate, now you have organs, and now you have structure. Could it one day be aware? Some of these strands of protein, as they go in, they become more complex. They interact with others. You know what I mean? So you might have what looks like, from the outside, looks like a dandelion, and just like all going in toward the center of this big molecular cloud. How big? Glad I asked. The galaxies that we measure, that we look at, right, the astrometrics that we have done, seem to indicate that all of the lit space, the stuff that we know, the 5% that we know what it is all spread like little bits of soap on the outside of these giant bubbles of empty space, or at least space we don't know what's in it. And it's possible that space is empty, probably not, but it's also possible that the matter in that space is fairly well evenly distributed, so we can see other objects through it because it gravitationally lenses things. That would be no problem. Einstein would say it doesn't matter how big or how small, how fast, how different, as long as you have enough mass, you'll bend light, right? So you make a big lens, it still bends light. Okay, so my idea is one of these giant pan-galactic family voids, several thousand light years across. In other words, huge. You could put, well, let's put it this way. I didn't mean several thousands. I meant several tens of millions of light years apart, some of them are. Other ones are tens of millions of light years apart or millions of light years apart. This is huge because our galaxy isn't that big. It's 100,000 light years by about 50,000. If I don't have that right, it's 200 and 100. Please let me know. But at any rate, compared to these voids, compared to the groups of galaxies and the voids that are inside those little groups of galaxies, a galaxy is pretty small. And these voids are very large. So consider that those voids are full of the same material that we see around us, just more tenuous, but the same chemical process will take place over time. And if it's sufficiently well distributed, we may not see stellar formation. We may see instead protein replication going inward. And when you get enough of that happening, you could call it life. If it interacts, if it recognizes its medium, if it reacts to that medium, right? And eventually it might become aware. So now we're talking about a creature that's, I don't know, 500 million light years across. It's not very complex at the outside, where the reactions start to take place. It might be like we think of our hair, right? But inside becomes quite complex. And all these different organs and differentiated protein areas and all the stuff that will eventually or might eventually become structure. Now, I'm at the extreme edge of this contemplation of panspermia, but this is what I was led to, considering your ideas. And perhaps you haven't looked at it from this point of view, that it isn't just one little thing in space, it is this whole idea. Well, what happens when you snowball it? Well, this is what happens. That's how you do physics. When you come to a block, you say, okay, we have to develop a new physics, a new calculus. That's what Newton did. He and some other people that he stole and borrowed heavily from um, were developing calculus. We're inventing calculus. Pretty cool. It was a very exciting time for left brain people. Anyway, so now we've got a living creature that's hundreds of thousands, if not a million light years across. Imagine that. It's alive. It looks like a dandelion fluff, right? Because it's just all these threads of protein precursors and proteins, and then more complicated as it gets in and in and in, thousands of light years away. So this is one of the concepts behind my Hornock's universe, that this takes place. And that the real life in the galaxy, we don't know. Not in the galaxy, in the universe, we don't know. Because it forms in these giant voids. And each life form that forms in these giant voids tends to become a single unitary animal or creature. And they're all different. Wow. So think of all the galaxies as being the sheen of a soap bubble, right? And each of those soap bubbles, inside it, is the amnion of the womb of some cosmic creature that's so vast we can't even conceive of it. And all our little lit universe is just spread on those. Kind of like sand on crocodile eggs, and you bury them. Wild Bill, it's the kind of thing I go through every day. This is how my mind works.